Good morning, ladies and gentlemen. Welcome to this class of fundamentals. I'm Tosca Johnson, who will be taking you through this class. And at this particular time, we are going to begin with the word of prayer. Our Heavenly Father, we thank you, honor you, we bless your holy name to have been with us, to make us, Father, to have this class today, and to those who are going to listen to this video. May we be able to understand each and everything that is required. Father, thank you. Release your anointing over me and over them in the name of Jesus. The course we're going to look at is GECC 1101. That's the code. And the course is called Fundamental Computer and Office Application. Regular program, that is 2019-2020 by summer session. The presenter that is going to be teaching us is called Tosca Johnson, for whom whose voice you are listening to. Objective have to look at the introduction of this course. When we talk of the word fundamentals, we mean the basics of computer. To look at the basics of computer, not looking at it in details, but just a few things that we need to handle or to look at. Introduction. What is a computer? A computer, it is an electronic programming machine that accepts data as input, processes it, and gives output in form of information. So as we know, all of us that have been dealing with most of the electronic device, there is no any electronic device that you're going to use without having a software installed on it. It may either be embedded on it or it may be directly installed. Are we together? So that's why we're saying that a computer is an electronic device. Indeed, it uses power for it to be able to be used by any other person. And we're saying it is programmable because we use softwares for us to be able to use this machine. A computer, to be a complete machine, or to call it a computer, or where it got the name computer, it's a combination of two things. That means you have to be having the software and the hardware together. The combinations of the two, it's what I would call a computer. But if you're still having a software alone, we can't call it a computer because it cannot perform anything. If you have hardware as alone without software, it means it cannot also not do anything, because that's not a complete computer altogether. But unless if all of the two are combined together, that's when we call it a computer. So we are saying it is an electronically programmable machine that accepts. So by the sense of the software that is inside it, which can be able to understand the languages of our hardwares, then it will accept, as you, a user, you are pressing a certain button on your keyboard from A to Z, or numbers from 0 to 9. Everything can be typed. So the moment you press it, the computer, because of the sense, it will sense, because of the software that is there, it will be able to sense what you need, you as a user, and automatically it will display it as you need it. So after that, it will process that information. After processing it, and it will give it out as an output in form of information, depending on the requirements of the user. So that's why we define a computer, saying it is an electronic programmable machine that accepts the data as input, processes it, and give output in form of information. Then we have another definition. It is a machine electronic in nature. That machine is electronic in nature, in other words, it uses power, which accepts structured inputs. It will accept structured inputs, as I have just explained, processes it according to prescribed rules. So it will work according to the needs of the user, or according to the order or how it is being configured altogether. In bracket, a computer program that is using a software and produces the results as an output. Alternatively, a computer is a device that works under a control of stored programs. So when we say it works under stored programs, we have a software. It is always a system software that is always installed on our computer. So obviously it can be used like that, or when it is stored on a hard disk. Are we together? So storing automatically, accepting, storing, and processing data to produce information as a result. Are we together? So alternatively, a computer is a device that works under the control of stored programs, automatically accepting, storing, and processing data to produce information as a result. Is it okay? So I think there's nothing, unless if you have a question there, you can still raise it at any single time T. A computer is composed of two major components. One, we have hardwares and softwares. What is a hardware? A hardware is a physical components of a computer. When we say physical, in other words, we can be able to touch it. As I can be able to touch my phone, I can be able to touch my monitor, I can be able to touch my keyboard, I can be able to touch my system unit, I can be able to touch my mouse. I think that. So those are hardwares, and we have external and we have internal hardwares. When we talk of internal hardwares, we talk of RAM, we talk of a central processing unit, that is a CPU, we talk of a hard disk, we talk of motherboard. Those are inside within the computer, and other many parts of the computer which we call hardware. So a hardware is a physical component of what? Of a machine that you can be able to touch it physically and feel it. Whereas a software is untouchable parts of a machine. This one here, it's like a spirit of a human being. What I would call a human being is the real air that makes this person to move, that makes this person to talk. Are you getting that? But these flesh, the bones and the flesh, the muscles, those are just the hardwares, if I'm to refer to them. We cannot see it, but we can see it when it is loaded on a human being. When you see a human being walking and talking, so that person is normal. So a normal machine must have a software. The software is seen but not touched. So it's an untouchable part of a computer that assists a computer to perform its most tasks. Are we together? So we use a software. So a software is divided into equal parts. We have what I call application software, and we have what I call system software. So system software is one of the software that are always installed on our computers. In other words, they are the ones that sits on the hardwares. In other words, they understand the language of hardwares. Are we together? These ones, sometimes the system software, we call them operating system. I believe you guys, you know what operating system is. I know some of you have computers or you have phones that are smart, whereby you can be able to install a software. Are we together? So the system software is like Windows. That's an operating system. Windows XP, Windows 10, Windows 8, Windows 19, Windows 23, 2003. Are you getting that? Yeah, so all these ones are Windows, because are the ones that gives you platform for you to be able to use, to interact with the application and the hardwares. Are we together? So then we have application software. Application software, they are always divided into two equal parts. We have online application and also offline application. When we say online application, those are applications that will be able to be accessed through or over the internet. When we say offline application, those are the ones that will be accessed offline. Are we together? Or without internet. Those ones that can be accessed on internet are, we have, like for example, I want to register on ERMS of Bugema University, I need to have internet. If I want to send my email, I need to have internet. If I want to download a file from the internet, I have to have email. Those are the ones. Are we together? Using Google, using Firefox, using Opera, etc. But offline, this will mean Microsoft Word, in case if I want to write a letter, Microsoft Excel, Microsoft Access, Word Publisher, and so many others. So those ones there are the ones that we are turning at as what? As our offline application. Are we together? So that is briefly on this slide. Are we together? So a computer classifications. A computer are classified according to the number of ways this includes. So when we classify computers, there is a number of things that we normally consider. As you know very well, you guys, that we normally configure, we normally classify animals. Animals are grouped according to their characteristics. But for us in computer, we look at their ways on how they work or they do things altogether. First thing that we normally look at the mode of operation. How does the computer operate? How does it work? Are you getting that? Does it use digital? Does it use analog? Are we together? Now look at the purpose. What purpose does it serve? Are we together? What does it do? There are those computers that can be able to work within education sector, and there are those that can be able also still to work, and it can be able to work, and they can work under industries. For example, filling of a fuel into the jerry cans and putting the cork, or might be they can be able of uplifting vehicles, loading, doing what. So those computers are different, are not the same as what we shall be able to be using in our what. So they serve different purposes. Look at ATM in the bank. Not all the computers that are used in the bank can be able to serve, can be able to work as ATM. Am I getting that? Like, what are these people uses on the tellers? For them, they work on a single person, but serving directly with a human being. It's the same as this machine that I'm using the same. Are we together? So for this case, those ones are different. But again, when you look at the computer that are using the ATM, this does not need any human supervision. You'll need to reach there and be able to put in your card. As long as you have the credentials, it will be in position to assist you. So that is the purpose. When you look at the class, then you will see that the class, the size of the computer often determines its functions and processing capacity. Are we together? So now the class will have two ways. We'll have to look at the processing power. When we look at the class, we don't mean any other thing, but we look at the processing power. How faster the machine is, how good the machine is. Are you getting that? There is a machine, when you give it 1 times 2, it takes years to process. The same as a human being. When I go to class, like in this class, I can pose a question and ask, what is a computer? For example, I've just looked at what a computer is. You'll see that out of 100 students, or might be out of 200 students, or out of 10 students, 1 student will raise up the hand. That means he will rise up when others are still trying to digest, to see on how they can be able to do what, to handle or to answer the question. Are we together? So that is the processing power. How fast do you come up with the answer? How fast are you? So when we talk of the size, we mean the processing power. Is it okay? The size of the computer varies widely from the tiny to the huge, and is usually detected by the computing requirements. Are you getting that? So it will look at the size. The size does not mind, but what we look at how fast that computer is, whether it is big, whether it is small. Then another thing, we look at generation. Generation is, as you know, that we have the old Stone Age and New Stone Age, and there were some primitive stages. Again, getting that. So all those stages, they would move a human being to the old Stone Age to the New Stone Age. What was done in the old, what was done in new, that is the stage movements. Like when you're building a house, it goes in stages. All the stages cannot be done at the same time. Are getting that? And at every stage where you reach, there are new things that are done at that particular time. So generation means that there is the first computer we had. What was generation 1, generation 2, generation 3, generation 4, generation 5. And we have 5 generations that we are in right now. And you'll see that in most all those generations, the first generation, the person was coming up with the idea first. And coming up with an idea first is trying to see that what will be able to be happening at this particular time. Are we together? He will first see what is exactly happening, and is coming up with the fresh knowledge at that particular time. Automatically, it may not be 100%, but he's just trying to develop a concept. So as he develops the concept, are we together? He develops the concepts. He's trying to see how will that work, or that idea come. So the first concept, the first generation, the second generation, as we shall be looking at them, you'll see that generations were leading. Every generation, there were 2 different ideas that were done or that were coming up in that particular time. Then we have the design, which we call the architecture. How does the computer be arranged? When you build your house, always you have the architecture or the design. Where do you want the room to be? Your bedroom? Where do you want the sitting room? Where do you want the store? Where do you want this? So all those things will be done, and obviously they will be carried out according to your knowledge. And every stage has different ideas. Are we together? So we shall have mode of operation. Then now we start looking at them. A computer system may be classified according to the data they are designed to process, or mode of operation. And these are, as I said before, that when we look at computers, we classify them depending on what they're supposed to handle or what they're supposed to do. Are we together? For example, look at human being. Companies have different activities. There are people who can be able to work as accountants in the organization. There are people who can be able to work as technicians. I think that not all people who are there, they are all human beings, but they can't do the same work. Why? Because they were they have different different ideas and different activities that they can be able to handle. So even these computers, as we have, all of them are computers, but they have different data that you can be able to handle. For example, analog computers. The analog computers do not directly deal with numbers, but rather deals with variables measured along a continuous scale altogether. So when you're dealing with the analog computers, you have to be sure and you be careful that with it will not deal with jumping numbers. It will deal with direct counting numbers. In other words, 1, 2, 3, 4. So it will deal with them in order. Are we together? So that's analog in a continuous. For example, like the temperature of the room, as the temperature is increasing, doing that's those variations, it will be able to handle it. It uses a continuous variable for mathematical operations and utilizes a mechanical or electrical energy. Are we together? So it will use a mechanical, or it will use electricity. In other words, it will use either batteries, cells have to be installed. For example, look at a thermometer in the hospital. It is always used for that and to measure the temperature of a human being. So analog computers may be accurate within 0.1% of the correct value. So with these computers of ours, more especially these analog computers, for them, they have their accurate is always having an error of 0.1 altogether. So the correct value, that's why, for example, you see that you may end up having two answers in this case, whereby, for example, I can talk of 9.8 newtons and it's approximately to 10 newtons. I think that. So these are two, meaning that there is an error as you're getting the calculations. Analog computers can perform several mathematical operations simultaneously. So you can do simultaneous activities at the same time. Then we have digital computers. Digital computers operates on a discrete data. It works on a discrete data. In other words, that you can have numbers that are jumping, or one letter or one answer can be. You can have ranges of operands, or might be of answers. For example, I can say A is less or equal to 10. How many answers are there? In other words, A can either be 9, or 3, or 4, or 5, or 10. I'm getting that, but it cannot exceed 10. So all those ones that are below 10, because I'm saying A is less or equal to 10. I think that. So it can either be 10, or it can be less than 10. Either can have 9, it is less than 10. I can have 6, it is less than 10. I can have 5, it is less than 10. I think that. So it will always look at that. Is it okay? It will indeed look at that, and that thing will be done correctly. Are we together? So for it can have more than 2 or 3 answers. Are we together? It works basically by directly containing numbers that represents numbers, letters, or other functional symbols. So it can deal with different. It can deal with different directly counting numbers. It can deal with them, and again with other presentation numericals, letters that are presented by letters. For example, I've said A is less or equal to 10. Or other functional symbols. You can use different symbols. Multiplication can be done, that sign of multiplication, a plus, addition, stars, and so many other operands can also be done in this case. Hybrid computer. Hybrid computer systems is one in which the desirable characteristics of both the analog and digital computers are integrated. So with a hybrid computer, you expect that all the two, analog and digital, will be done. More especially, these computers are found in hospitals, where they may need to measure the heartbeat, or the rate at which the heart is beating. Are we together? So it will be done there. In intensive care unit, analog computers may measure the patient heart rate, temperature, etc. So it can do so many things. So these ones, after might be the measurements that is required may be done in analog. Then afterwards, within the same system, it can be converted into digital. So the measurements may then be converted into numbers and supplied to the digital part of the system, which will thereafter regulate the flow of a certain medication. Are we together? So after getting the analog, then it can be converted to digital. Then the doctor or a physician will have to look at what the digital is trying to give out, and so that he can be able to think of what a medication he can be able to give the person. Are we together? So look at the purpose. The purpose will have two things that we have to consider. First, we'll have the special purpose. We'll have the special purpose in which the instructions are stored in form, on firmware, in a firmware, or wired into or permanently stored in the machine. The processors installed. So here in this first one, we are saying we have two in the purpose. What we have to consider, that the first special purpose, the computer in which the instructions are stored. Instructions are stored where? These are the operating systems now that are there, the programs that are there, which makes us do. So it can be a firmware or wired. When we say it is a firmware, it means it may either be permanently stored, it can be permanently stored on our machine, or it can be wired. Are we together? Either it can be embedded. Embedded means that you get a photo of that particular thing and probably you put it there and then you start using it. Are we together? So it's not a real photo, but it's like a virtual thing, but not a real machine. Because, for example, look at these computer or laptop or phones of ours. These phones doesn't have a hard disk where to install the operating system. But what do they have? They have the chips on their small motherboard. So you cannot put the entire operating system. So what you do, you get a virtual operating system and install it there, which is not a real operating system. Are you getting that? So that's what I'm getting that. So with the second, we'll have the general purpose digital. The computer, by using different stored programs, can thus be used in countless applications. The versatility of these systems is limited only by human imagination. So in this case here, what we can do, we can get the operating system and then be able to store the program into the machine and be able to continue working. We install it and do the operation, meaning that the machine has a space where we can be able to install these applications, to install it, and then where we can be able to request it from and be able to take it. And that machine is working beyond the human imaginations. We cannot know, we cannot tell that this thing is doing what is done. So this is the second, and what we are looking at the purpose. So we are looking at the second one, which we are calling the size. When we talk of the size, we mean that here we had already talked about this, and said we are trying to say that in this particular time, when we are talking about the size, we mean the computing power, the processing power for how faster the machine will be done, how faster the machine is. For example, if I say 3 times 5, how much do I need to get? Are we together? So in this case, I will be able to see whether the machine is working, how faster is it? Is it fast? If it is not fast, it means that its processing power is not doing what? Is not faster. So we look at the speed. It's like, for example, when you are given a vehicle and it is moving at 100 meters per second, and another one is moving at 200 meters per second. Obviously, when it is moving going to Kampala, the one that is moving at 200 meters per second will reach Kampala before you. So its speed is higher than you. It can even find you in the way and overtake. It can do much more work than you can do. So that's the size that you're looking at, or sometimes we call it a class. So in this case, we look at these machines. So for example, we have a supercomputer. Are the largest computers. They are the most powerful and most expensive and the fastest capable of processing trillions of instructions per second. So a supercomputer is the largest computer that always works faster and can be able to process any instruction that is sent, trillions of instructions within a minute. It can execute trillions of instruction, which is a bit hard to might be in the world at this particular time. This computer, I would say it's big because it can, we don't think that even the whole world will have trillion instructions that can be sent at a second. It's not there. You're getting that? Unless if you have to make our goats and our cows to start doing what? To be connected online, that's when this computer can be answered. And this computer will be used by much more companies that are dealing with with the complex data. For example, the users of the computers are governmental agencies. That's one. 2, such as the National Welfare Services and the National Defense Agencies in the company or in the government. These ones here will be able to use this. Also, they are used in making of movies. So for them being the fastest machines and so capable and so expensive, and they can work, their speed is too high, then they can be used to make movies. Remember, movies are always comprised with graphics and voice. Are we together? And all these things don't need delay. In other words, they need things which are faster. So we use them to make movies. We can even use them to design cars. We can use them to design most of the things that we need. Are we together? So it's very important for us to have these machines. Yes. So let's continue to another one. So we go to what I call the mainframe. A mainframe is the second largest computer called a mainframe. Mainframe computers processes data at a very high rate of speed, measured in millions of instructions per second. Are we together? So in this case here, we have a lot of things that are supposed to be done. Things to be done. So in this case here, these things here is actually this computer here is actually used by companies like Bugema, whereby it's bought by millions of dollars, but it can be bought by any company, and it can execute millions of instructions per second. Are we together? So it can be done quickly, and everything can be done there and then. So they are expensive, costing millions of dollars in a second. Mainframe designs for multiple users and process a vast multiple of data quickly. Banks, like for example, banks, insurance companies, manufacturers, mail orders companies, and airlines are typical users. The mainframes are often servers, computers that controls the network of the computers. So what I'll call the mainframe, and we are using it in most of these companies. We can use it in most of the companies that are beginning or the companies that have existed. This computer can also be able to answer millions of instructions within a second. Are we together? At the moment, Bugema, I cannot think that we'll have millions of instructions at a second. They are not there. So what I call a server is a dedicated machine that is responsible for administering errors, or to check, or to serve a certain service. Are we together? So we call it a server. Whereas we who are requesting from the server, we are called clients. Are we together? So this thing will be done quickly. Then when I go to another one, we have a mini computers. Mini computer systems is a small general purpose computer vying in size from the desktop model to the unit size of the 4-drawer filing cabinets. So this is a small computer that can be able to fit on a desktop and be able to use it as a single user, or even it can use a number of some people out together, like 2 or 3 or 5, depending on how it has been configured. It is quite obvious that there is a tremendous amount of similarity between more powerful micro and the lower end minis. So mini computers and micro, they're almost the same, because these ones, you'll see that these ones here is sitting on the desktop. They all have microchips. They use a motherboard, they use hard disk, they have power supply. Getting that? These situations exist on the other end, where the lower priced mainframes are almost similar to the high priced mains. Are we together? So their price, they are almost the same. So in this case, everything will be fine. Are we together? Yes. So